Okay, we're going to talk about right triangle geometry, and which is nothing new to you because you should have done this some in 6th grade, some in 7th grade, maybe a little bit in geometry too, so this is all no surprise to you as you go through it. So let's look at a few things. We're going to use right triangles to evaluate trig functions. We're going to find function values for 30, 45, and 60 degrees, or pi over 6, pi over 4, and pi over 3 radians. Use equal cofunctions of complements, and use right triangle trigonometry to solve applied problems. So let's look at a few concepts. First of all, now this is our basic definition for sine. Now sine, right triangle definitions of trigonometric functions. Now usually these only work with right triangles, so therefore sine is length of opposite side over length of hypotenuse on a right triangle. A over C. I always say O over H, opposite of hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. In general, the trigonometric function of theta depend only on the size of the angle and not on the size of the triangle. I always remember these functions by going through it as SOHCAHTOA. 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 Sine is opposite of hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. SOHCAHTOA. Cosecant, that's the opposite of sine, so it's hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. So in general, the trigonometric functions of theta depend only on the size of the angle, not the size of the triangle. Find the value of the 6 trigonometric functions in the figure. Okay, we begin by finding c. So we could use a squared on a right triangle, Pythagorean theorem, a squared plus b squared equals c squared. And if we did this, 16 plus 9 is 25, square root is 5 or negative 5, but we're dealing with a side of a triangle, so it has to be 5. Now if we start writing down our function, sine of theta is opposite over hypotenuse, 3 over 5. Cosine of theta is adjacent of my angle. Now opposite side, opposite is always opposite my angle. Adjacent is the side that makes up the angle that's not the hypotenuse. So on here, adjacent over hypotenuse is 4 over 5. Tangent of theta is opposite over adjacent, 3 over 4. Now, the other 3 functions are just reciprocal, so cotangent of theta is 4 over 3. Secant is opposite of cosine, which is 5 over 4. And cosecant is opposite sine, which is 5 over 3. So we can get our values very easily by using this rule. Now, a right triangle with a 45 degree, or pi over 4 radians, the angle is isosceles. That is, it has 2 sides of equal length. So, from here, if we know the sides are 1 and 1, we know the hypotenuse is square root of 2. So on a 45, 45, 90, we know the sides we're going to deal with majority of the time are 1, 1, square root of 2, and that works. Remember, the size of the triangle doesn't matter. So if this was 2, 2, this would be 2 square root of 2. If this was 3, 3, it'd be 3 square root of 2. So this is the basic triangle. Now when I always draw a formula triangle out for 45, 90. And so I say x, x, and x square root of 2. Now on a 30, 60, 90, or pi over 6, pi over 3, pi over 6, pi over 3, yes, on 90, the sides are 1, square root of 3, and 2. So the hypotenuse is always, so if I drew my formula triangle out on the 30, 60, 90, that's a terrible 30, 60, but that'll work. Always opposite my 30. Opposite my 30s is going to be x. Opposite my hypotenuse, opposite my right angle is 2x, and my longer leg is x squared root of 3. And it's a little different than this picture, but it's always opposite my 30 is my x. And usually x on here, on most form times, we're going to treat it as 1. So it'll be 1 square root of 3 and 2. You'll notice it can change around how it works. So here, let's use the figure to find cosecant of 45. Well, cosecant of 45 degrees we know is hypotenuse over cosecant of sine opposite. So we look at the 45 degrees angle, so it's hypotenuse, which is square root of 2 over opposite side, which is 1, which is the square root of 2. Now secant of 45 degrees is hypotenuse over adjacent, which is square root of 2 over 1, which is the square root of 2. And cotangent of 45 degrees is adjacent over opposite, which is 1 over 1, which is 1. Now use the figure to find the tangent of 60 and a tangent of 30. Notice there's two different angles here we're going to work with. So let's do tangent of 60. Here's my 60-degree angle. Tangent's opposite over adjacent. So opposite 60 is square root of 3. Over adjacent is 1, so it'll be square root of 3. Now tangent of 30, we're going to use this angle instead. Tangent of 30 is opposite over adjacent. Opposite is 1. Adjacent here is going to be square root of 3, which rationalizing the denominator is equal to square root of 3 over 3 as we go through it. Now some of the functions, the basic functions as we go through here is this. Sine is 1/2, cosine square root of 3 over 2, tangent square root of 3 over 3. Sine of 45 is square root of 2 over 2, square root of 2 over 2, cosine, tangent, and 60. Some of the basic functions we should know about as we go through. Now two positive angles are complements if their sum is 90 or pi over 2. Any pair of trigonometric functions f and g are which f of theta equals g of 90 minus theta, or g of theta is equal to f of 90 minus theta, are called cofunctions. So in other words, if we look at these two rules, got 90 minus theta and theta, we can look at these, that ends up being theta 90 minus theta as your angles. So now let's look at some confunction rules. We get sine of theta is equal to cosine of 90 minus theta. Cosine theta is equal to sine of 90 minus theta. These are cofunction rules. Sine and cosine go together. Tangent theta is equal to cotangent of 90 minus theta, and cotangent is equal to tangent of 90 minus theta. These are cofunction rules, and same with secant and cosecant. Now we can replace 90 degrees up in this formula with pi over 2, and it means the same thing. Pi over 2 is dealing with radians, 90 is dealing with degrees. So let's say find the cofunction of the same value of the given expression. So if we had sine of 46, the cofunction would be cosine of 90 minus 46, which is equal to cosine of 44 degrees. Now tangent here would be tangent. Now since this is radians, this is going to be pi over 2 minus pi over 12, which is equal to tangent, if I got a common denominator in here and everything like that, if we have tangent and then common denominator would be 6 pi, so it would be 5 pi over 12. So, a couple things to look at as we go through here. Now the last couple of concepts here. An angle formed by a horizontal line and the line of sight to an object that is above the horizontal line is called the angle of elevation. the angle formed by the horizontal line and the line of sight to an object that is below the horizontal line is called the angle of depression. Notice here, angle of elevation goes up to the object, angle of depression goes down to the object. Now the angle of elevation would equal angle of depression is the same as the angle of elevation as we work it out. They're the same measure. So let's look at this object. Irregular blue-shaped lake is the figure that represents a lake. The distance across the lake A is unknown. To find this distance, as the vertex of measurement shown in the figure, what is the distance across the lake? So if I look at the angle and the sides I have the opposite side and I have an adjacent side. I'm going to use tangent on this one. So we're going to say tangent of 24 degrees is equal to A over 750. And I think I put this over 1 and cross multiply. I'm going to have A is equal to 750 times tangent of 24. Now I might go to my calculator and solve that one down a little bit here. And I got 24 degrees, so I'm going to have to go through here and say settings, handheld setup, wrong one, cancel, settings, document settings. I'm going to have to change this to degrees now. Okay. And then I'm going to go over here, and it's going to be 750 times tangent, and I believe it was 24 degrees. Enter. Oh, didn't get the right answer. Control Enter. So it was 24, 333.92. So A, 333.92. And I don't know if it was feet or yards across the lake. So make sure you get the calculator in the right mode and all that when you're doing these problems too, as you solve them down. So what I'd like you to do for tomorrow, I think that was the last slide, yep, is let's say we do problems 17 on page 533. And then number 50. Thank you.